Hi, let's take a look at question number 2. Number 2, it says that the penguin population on an island is modeled by a differentiable function p of time t, where p of t is the number of penguins and t is measured in years, and for t between 0 and 40 inclusive, there are 100,000 penguins on the island at t equals 0. Even though it changed in penguin, but it sounds like the water in and out problem. So let's take a look at this. Is that the birth rate for the penguin on the island is modeled by B of t, and the death rate for the penguins on the island is modeled by D of t. So the birth rate basically is the rate in, the death rate basically is the rate out. Give birth going in, the death rate, that means they're gone. So we are going to transfer what we learned in the water in and out problem into other type problem that had the same concept as the water problem. So even though the subject changed, but the idea is still the same. So we still have the initial amount, we still have the rate going in, and then we still have the rate goes out. So let's take a look at the information here. So we basically have the rate in, which is the birth rate. That is B of t. And then we had the rate out, which is the death rate, which is D of t. So we still had the initial amount given, and we got 100,000 penguin in this time. So essentially the idea is the same. It just changed the type of stuff. Now let's take a look at part A. So what is the rate of change of the penguin population on the island at t equals to 0? Keywords: rate of change of the penguin population. So rate of change, it means slope. Penguin population is P of t. So you basically find the slope of P of t at t equal to 0. So that means find P prime of 0. So all this, it means find the slope of P of t at t equals 0. It means find P prime of 0. So now we just have to find the P prime of 0, and that would be part A. So P prime, so equal to what? It's going to be the rate in minus the rate out, just like what we did before. P prime will be the rate in minus rate out. So in this case, P prime is going to be the birth rate that will be in, and the death rate that will be the rate out. So P prime of 0, that will be equal to B of 0 minus D of 0. We can use a calculator to solve this one, and I decide not to because it's e to the 0, so it'll be easy to solve. So now I am going to put 1,000 times e to the 0.06 times 0 minus 250 times e to 0.10. So you can skip step. I'm going to show all the detailed step. We got 1,000 times 1. E to 0 is 1. And then you get 250 times 1. So you get 1,000 minus 250. So therefore you subtract, you'll get 750. So the unit of B of t and D of t, they both are penguins per year. So after you subtract, it's still penguins per year. Of course, you don't need to write a unit if you don't want to. It never asks. Now we finished part A. Let's take a look at part B. To the nearest whole number, what is the penguin population on the island at t equal to 40? even though we change the subject into penguin, so basically it still had to find P of 40 because P equal to the population. So we're going to use the same concept like the water in and out problem. So we're going to do 0 to 40. The rate going to be in is the birth rate, and then 0 to 40, and then rate out, which is the death rate, and then plus the initial amount, 100,000. So now we're going to type this in our calculator. So we had to do y1 is 1,000 times e to the 0.06x, and then 250 e to the 0.1x, 0.06, 0.1. So now we're going back to math 9. We got 0 to 40. One, two, three, four, five. Okay, now enter. So we've got the number. So we get 133,057.5646. In the question asked to the this whole number, we're gonna round it 133,058 penguins. So we finished part B. Let's take a look at part C. Part C. To the nearest whole number, what is the average rate of change of the penguin population on the island for t between 0 and 40? You have to find the average rate of change of the penguin population. Average rate of change of the population, slope of the population, the slope of P. So that means average of the P prime. Average rate of change of the penguin population is translated into the average of the slope of the P. In other words, the average of P prime. So if you want to find the average, we have to do integral a to b, P prime, okay, and then b minus a. When you find the average of something, you always have to integral. So if you have to find the average of the P prime, so P prime had to be inside the integral. So in this case, we're going to do is 0 to 40, P prime of t dt, then 40 minus 0. So now we just let the y3 equal to the the rate in minus the rate out. Okay. Okay, we did that before. So now we just have to do integral 0 to 40 y3 dt, and then divide by 40. So now we do math 9, 0 to 40, and our y3 is going to be the b of t minus d of t, the rate in minus rate out. So now, and divide by 40. So we got 826.439. And we want to get the whole number, so we round it to 826. So we got 826.49, we round to 826. Of course, there's another way to do this question. So if you want to know, so let's take a look at method number 2. So we get integral 0 to 40 p prime of t dt over 40 minus 0. p prime, the antiderivative is p. So we get p of 40 minus p of 0 over 40. We already found p of 40 in part B, and we know p of 0 in the beginning. So p of 40, okay, so let's take a look at what we got. P of 40, we got 133,057. We still have it in our calculator. Okay, 0.5646 minus the 100,000 divided by 40. So now we're going to do 133,057.5646 subtract. Okay, 1, 2, 3, 4, 5. Okay, and then divide by 40. We got the same answer, 826. So therefore, we got the average rate of change. So this is going to be penguin per year if you want to know the unit, because this is penguin, this is year. So we got the penguins per year if you want to know how to find the unit. Okay, so we finished part C. Let's take a look at part D. Part D. To the nearest whole number, find the absolute minimum penguins population at the absolute maximum penguin population on the island for t between 0 and 40. Show your work. So for part D, we had to find the absolute max and absolute mean of p of t. So very similar to what we did before. So we're going to use p prime of t equal to 0. And then we're going to find the lattice max, lattice mean. If there's only one of them, then we found the answer. If you had two lattice max, you have to compare. You got two lattice mean, you also have to compare. So we got p prime of t equal to the rate in minus the rate out. In this case, it's the birth rate and the death rate. So p prime of t equal to b of t minus the d of t. So p prime of t equals 0. So that means b of t minus d of t equal to 0. So we use the same strategy as we did in the previous question. So we got our y3 equal to y1 minus y2. In other words, our y3 is b of t minus d of t. So we're going to graph the y3 and see when you get the 0. So now we go back over here. So let's unhighlight the y1 and the y2. And the window, we're going to make it into 0 to 40. So let's make it into negative. The number is kind of big. So let's make it negative 1,000 and 1,000. Okay. So we're going to graph. So it looked like there's only one critical value. If you want to do zoom 0, then you can have a better picture. So we're going to get only one critical value. So let's find what number that is. So we're going to get 34.657359. Okay, so now let's make a simple sketch. It look like this over here, 34.657359. So now simple sketch 0, 40. So this T1. So we get positive, negative, positive, negative. So we got P0 and P40 relative. So we just sketch this. So we got P of 0 and P of 40 are relative mean. And then we're gonna get P of 0 is also relative mean. And P of T1 that's going to be relative max. And this is the only max, so it's gonna be the absolute max. So P of 34.657359 is the only relative max. So therefore the absolute max. And then we're gonna find out how much that's going to be. Okay. And then P of 0 equal to 100,000 and P of 40. Okay, so we got a before. So it was 133,058. So they both are relative mean. So definitely this one is going to be smaller. So we go the absolute mean that is at t equals 0 is 100,000. So now we still have to find the absolute max. So let's go back over here. So let's recall our memory. So I don't have to type it again. Okay, so now I am going to clear this. I have to type in 34.657359. 34.657359. Okay, so now I am going to press enter. Okay, so right now I'm going to get is 139,166.6. 139,166.6. So we're gonna round it 139,167. Okay, so now we found the absolute max and the absolute mean. We finished question number 2.